So, looking at vector addition then, a quick reminder that vectors have magnitude or size and direction, and examples are velocity, displacement, momentum, force. There's lots of examples. Scalars only have magnitude. And examples of that: speed, distance, energy, temperature. So, if we're adding scalars, if we have 5 joules of energy and we gain a further 5 joules of energy, well, we'll have 10 joules of energy. Dead easy. However, with vectors, if you have 5 newtons that way and you have 3 newtons that way, you have to consider that this 3 is in the opposite direction to the 5, and so you end up with 5 minus 3, which is 2 newtons. So if things get a little bit more complicated and you say, well, my 5 is going this way, and remember that the length of the arrow is an indication of the magnitude of the force, so this arrow should be 60% of the length of that one. And let's say I've got my 5 newtons as I had before, but now I've got my 3 newtons at this angle, which just for now I'll call 30 degrees. I'm going to have to be more precise in a minute. So this 3 newtons, that has a little bit of a horizontal effect and it has a bit of a vertical effect. So we've got a horizontal component of the force and a vertical component of the force making up our 3 newtons. So we have to consider that when we put these two together, some of this is going to make the 5 bigger and some of it is going to provide a vertical bit the 5 doesn't have right now. So there are 2 ways of doing this. We can do it by calculation or we can do it by scale drawing. And at GCSE, we do it by scale drawing. So what we would do is we would take some graph paper and this is where we have to get really precise. We would say, well, we have a 5 centimeter line, 1 newton, 1 centimeter. So we can draw a 5 centimeter line. And there is my 5 newton force. And then I get my protractor. And I said it was at 30 degrees. So if I mark my 30 degree just there, and I go 3 centimeters, from the end of my 5, which is there. Now I have measured that angle to be 30 degrees. So my 5 newtons and my 3 newtons would have the same effect as a single force like that. Now you should be doing this with a sharp pencil. I'm doing it with a pen because it's easier to see on the video. And that line is 7.8 centimeters long, so that I read to be 7.8 newtons. And because it's a vector, I can't quote it unless I quote the direction as well. So now I have to measure my angle. And my angle is 14 degrees. So my resultant is 7.8 newtons. And you might say, well, I only had this and this to 1 sig fig, so that is 8 newtons at an angle of 14 degrees to the 5 newton. And that is my answer. Now notice that I drew the 5 newton and then I drew the 3 newton nose to tail with that. So I started and I went this far with the 5 newton, and then I said, well, I've got a 3 newton in this direction to add, so I started the back of my 3 newton here, so that I start here and I end up at the end of the last force or velocity or acceleration vector, whatever the vectors are. And my resultant then goes from where I started to where I finished. So that's how to do that. Now let's take an example. Let's say a Tesla car, Model S, has a force of 100 kilonewton, 100,000 newtons, applied by the motors horizontally forwards. Let's say we have frictional forces of let's say 10,000 newtons acting horizontally backwards. And air resistance, and I'm only going to consider the air resistance acting on the windscreen at this point. Just to make things simple, give us a nice easy angle to work with. $60 degrees to the horizontal, and 20 kilonewtons. And the first thing we want to do is to calculate the resultant force horizontally. So we have ten kilonewtons reducing the 100 kilonewtons that we had before. So we have 100 minus 10 is 90 kilonewtons due to the motors and friction. And we have a force of 20 kilonewtons, a 60 degrees to that. So if you just sort of sketch that out, you've got a force like this of 90 kilonewtons and a force like this of 20 kilonewtons, and that's 60 degrees. That's kind of the way I'm thinking, but now I have to draw it properly. So I'm going to say 9 centimeters, so 1 centimeter to 10 kilonewtons. So let's do that. So if I go 9 centimeters to there we have our horizontal force. And we also have a downwards force. Let me just rearrange this now. I've done that wrong. I need my 9 there, because I haven't got space to draw the. So there's my 9. And now I'm going to come in and say I want a force at 60 degrees to that. So there's 60 degrees there, and I want 2 centimeters. So if I put the 12 centimeter mark on the end, and I come down to the 10 centimeter mark there. So there I have my 20 kilonewtons, and that's my angle of 60 degrees. So my resultant then, going from where I started to where I finished, that's 8.3 centimeters long. So that's 83 kilonewtons. That was 90 kilonewtons. And then all I have to do is to measure my angle. And my angle is exactly 10 degrees. No, it's not. It's exactly 12 degrees. So I have a resultant of 83 kilonewtons at an angle 12 degrees to the 90 or 12 degrees below the horizontal.